5 minutes goes quickly. Good day, everybody. Our company is Ambixtra. We're a technology development company from South Africa. We have a development center in South Africa and a business development office in France, where I'm based full-time. Basically, today I'm going to briefly introduce you to two technologies that we have, and they are electronic spark ignition technologies, one of them being a variable spark ignition and the other one being an advanced plasma ignition. Basically, these technologies solve ignition challenges that engine developers are facing going forward in terms of the new engine development strategies they're following. So we all know that there's ignition targets, and obviously these ignition targets are driving engine developers and OEMs to radically change their gasoline engine designs going forward to meet the CO2 emission targets. So typical strategies that have been followed are downsizing, boosting, leaner air fuel ratios, and high EGR percentages. These are just a few examples. Stratified combustion, for example, at Mercedes-Benz, and then alternate fuels as well. Problem with these new strategies is ignition is the central theme to combustion. So what the developers are finding now is that under high pressures and high EGR percentages and sort of leaner air fuel ratios and very much so in stratified conditions, current ignition systems are battling to operate efficiently. And this results in adverse effects happen, and you end up with cyclic variations, misfires, etc., etc. We believe that the ignition challenge is quite significant if you consider the fact that IAV in Germany, half owned by Continental and VW AG, recently, 2 years ago, initiated a global ignition conference. And that was held 2 years ago, and the second one was held last year in November. So for us, that's the litmus test that ignition is a challenging environment. Typically, what is coming out in the ignition space at the moment to meet the challenges, guys are coming out with high energy coils, multi-spark coils, and plasma and laser R&Ds taking place. What we see in many of these cases is that the suppliers are manipulating existing technologies. So you're ending up with ignition pencil coil systems which are big, bulky, sometimes complex and expensive. You've got multi-spark issues that affect spark plug wear, plasma systems that are destroying engines, and many times they're not plug and play, so they don't really fit in well with current engine architecture. So we've got a solution, obviously, and it was invented at Northwest University. And basically, it's the core to our technology, and it switches high voltages and high currents at high frequency with low loss. So product number one is what we call variable spark ignition. And with this system, we can precisely control the duration of the spark. We can precisely control the strength of the energy, and we can provide a continuous spark if required. And during that continuous spark, we can vary the energy. So for example, we can map the system via the ECU to give whatever appropriate spark you require depending on the conditions of the combustion chamber. And if all the above isn't good enough, we can give you some intelligence as well so you can decide what is the best spark depending on the combustion conditions. Obviously, that translates into benefits. We've done extensive testing over the years as we've matured our product. So we are seeing reduced CO2 emissions, leaner air fuel ratios, higher EGR percentages, and our system operates and assists in achieving these environments. We're finding we're getting reduced cyclic variations, we can extend knock limits, and cold start, which seems to be an issue as well, is drastically improved. The nice thing is, and you saw on the previous slide, our system is basically the same size as a low technology pencil coil. So it's completely plug and play and applicable to current engine architectures. Our systems are underpinned by 5 patents that span across the electronics as well as the mechanical design. We've matured our product over a couple of years already, so we've done extensive testing at IAV in Germany on a couple of 4-cylinder engines, a couple of 1-cylinder engines owned by them, owned by Peugeot. We spent time at AVL and we put our system on there, demonstrated a car and drove around the test track. We've done motorcycle engine testing at Ambixtra, France. We've done engine testing at Fiat CRF, and we're busy following the technology readiness process with PSA at the moment, and we're exploring gas engine applications via EDRD in Spain. Our next product is the plasma ignition, and there we've got demonstrators. And obviously we realize that OEMs are reducing their tier 1, so we realize that we will not be in a position to manufacture. So we will have to be looking at doing partnerships with existing tier 1s. Thank you so much.